This is going to be a little different. Welcome everybody. This is the third to last TypeScript type challenge. I hope you didn't come expecting something different. This one we're not going to solve. So if you don't want to see a non-solution, or wait, I guess it would be if you do want to see a non-solution, then stick around. But I'm going to talk about why we're not going to solve it. This challenge is assert array index, and basically, it's kind of not solvable, I would say, is the nicest way to put it. I think there's this, jumping straight to the PR. I mean, the basic history of it is it was done a little different, and it's done by UID 11. So if you don't know, UID 11, this person here on GitHub has made many really fantastic challenges on the type challenges, and we're very grateful for their work. But it just is the thing that this one is not so great. And I couldn't actually get any solution to pass. If you check on GitHub, there are 8 or 9 solutions where people have tried, including the author. And as of this moment, I believe, hopefully I'm not wrong, but if you take these solutions and put them into the current tests, none of them pass. There was this really kind of nice answer by Yao Zhao written here. And they didn't solve it, but they tried to say some nice things about what it could be useful for. And pause your screen if you'd like to read this. I think it's actually kind of a good write-up. But what we're going to do today is Mike has volunteered. Hi, Mike.
Hello.
Mike has volunteered to sort of talk us through what it is getting at, because I think what it's getting, well, he'll tell you what it's getting at is actually pretty interesting. We'll look through a solution as it used to be, how it used to work, and then we're going to call it a day on this one. So Mike, handing it to you. Do you want to, what is this one? Tell us what it's all about.
Yeah, so fundamentally, this challenge is all about a concept called branded primitive types. So what this means is the practical problem we're trying to solve is we have a matrix and we want to loop through that matrix. So we're looping through that matrix using the indices I and j as you do. So we loop through I equals 0 to matrix.length, and then we loop j equals 0 to columns.length. What we want to prevent, super common scenario, we mix up I versus j.
Mm-hmm.
So if we mix up I versus j, we will probably get some sort of runtime undefined condition. So this is something we're interested in checking at the compile level. So this is kind of difficult as I and j are both just numbers. So how could we ever sort of disambiguate between two different numbers on the type level? So we do that via a tagging system. If we scroll down a little bit.
Can I just mention there is a flag in TypeScript for this, no unchecked index access, but it's not really what we're shooting for because it just checks that the value isn't undefined. And of course you could have a value stored as undefined. There are ways this is maybe not going to be the real solution to what we're shooting for.
I can speak a little more about this. Yeah, the issue here is that it just always creates, no matter what, if you access an array using a number, it's always going to be maybe undefined if we pass in just a wide number type. Mm-hmm. This is kind of verbose and inconvenient. And it also doesn't really check on the type level whether a given index access is correct. It just always assumes it might be incorrect.
Mm-hmm. Yep. All right.
So here's the sort of interface of the solution that we want to go for, or a proposed interface for solving the underlying problem. So stepping through this step by step, we have a const numbers equals 57. So this is being typed as just an array of numbers.
Yep.
We are asserting that numbers is an array that has some sort of index called numbers. A little confusing. But what this does is it adds a data structure to that array on the type level that contains an index of what it can access.
That's the branding part. That's where the branding comes in, right?
Exactly.
And people also call this tag types as well. There's a challenge about tags. So I don't think you and I did it. I think it was Andrew Burgess and I did it, but yeah.
Yeah, tags are super useful as well. And then in this clause of the for loop, we're saying I is equal to 0, but it is also something else. We're saying it's an index of the array numbers. And what this allows us to do, even though we don't know how long numbers is or what it contains, what it's saying, we're asserting that the variable I is the only valid index into numbers. And if we try to access it via any other element, if we try to access it via a literal number or like a different number, then or a number constant, it will fail on the type level. So that's the interface of the solution, and how to get there is a little more complicated. But before we go into that, we can scroll down a little bit and talk about, so this is the full example whereby we're looping over that matrix again, and we are asserting that the matrix has some index called rows.
Yep.
And then in the for loop, we're asserting that I is the only valid key into matrix. It's the only way to access values on matrix. If you try to pass in anything else, it will fail. So then we're saying each column has a like type level index called columns. And then in the nested for loop, we're saying J is the only valid key to access that column. And if you try to access it using anything else, you will get a number or undefined. So it won't quite fail. It will just tell you, hey, it's not guaranteed to actually have an underlying value, unlike J.
Let's see it in practice real quick. So although the current tests, or for whatever reason, again, I tried very hard. I hope I'm not mistaken on this, but I couldn't get any of them, including the auth. So this is UID 11's solution to their own challenge. And this solution today does not pass the tests. They must have changed or been updated or something. But basically, I want to show this exact thing here in the code in action. So we have our matrix. It's exactly what we were. Let's zoom in a tiny bit. Oh, it's so big if I do that. Okay, that's all right. This is what Mike was just talking about. So again, I has been cast to type of matrix. And again, if I it's kind of fun. If you hover over matrix, you can see a little bit beneath the curtain, what's actually going on here. So we have rows and we have a code, and then that code maps to number array. So there's some interesting stuff going on, but we see that we're allowed to index with numbers that match, that index with I into matrix. We're also not allowed to index with 0, like numbers directly. Great. Then if we come down here, columns, it can only be indexed with J, and J is the same sort of thing. If we hover over columns, we're going to see that before we did any assert array index, it has just number array. But after this line 234 here, it's just, it's got this other stuff, Mike just said, we're appending to the data structure. And here's the error. Ready? That's a J. Now it's an I, and we get an error. So we see here, object is possibly undefined. And that's what we're shooting for. That's that error there is the whole goal of this whole thing.
Yep.
Yeah.
And I can, if we want, I can kind of start to describe how this solution works, or the high level approach of how this solution works. So let's actually scroll down and hover over one of those, hover over I, for example.
Okay.
So, or hover over matrix.
Yeah.
So what we're doing here, so we are saying this item, the important part is the first clause in the intersection and the last clause in the intersection. So we say number array. So what that means is if we access it using anything, we get a number array out of it. Good. Since we have that compiler flag enabled, we get number array or undefined. Then the last clause, read only 194, is saying if we pass in the particular value 194, then we get a actual number array that is not undefined. And then we're merely saying that I is that 194 value on the type level. One reason to dislike this is that we are lying to the type system. I is actually not just the number 194.
Yeah.
But this is a trick that we're using to sort of force the type system into this situation. So
would this work if I put if I put a string here? Is this going to be no? Okay, wait. Number. Wait. One second.
Yeah, it will work. It's just it won't work for sort of like simple reasons right now.
Okay. All right. That's. I won't go there.
Yeah, but this will sort of generalize to any sort of like data structure you're accessing. One aspect. So I think it would be instructive if we name both of the indexes to be rows.
Mm-hmm.
So on, actually, I don't mean that. On line 2, 3, 4.
Mm-hmm. Oh, okay.
Yeah. If we do this, then if we change 237 to I.
I mean, that's really what 240 shows.
Oh, yeah, exactly.
It's not an error.
Yeah, it can't disambiguate between these now. And that's because what we're essentially doing to come up with what that value is we're hashing this string identifier. So that's why you see in a lot of these solutions, we end up hashing a string or performing some like type level hash operation.
Yep.
This is because there's no source of non-determinism on the type level. We can't just generate a random number of any type. So I think is probably as far as we should take the explanation. What do you think?
Could I just have one question, like one curious question. This part where like it's a thing and then we run a function and it's like suddenly becomes another thing. Could you tell me how that happens?
Yes, I love this particular aspect. We're using an assertion operator. So this function in the return type, we see asserts array is something else.
Yes.
So what assertion does is it performs a intersection with whatever you're asserting it to be. You can use this to perform a lot of very interesting mechanics that kind of tie in the value level with the type level. For example, one thing you can build is a type safe set, where if you do set.insert, you in like pass in foobar, later on you can do set.has, pass in foobar, and then the return type is true. So that's what we're doing here. So we're tagging this matrix variable with additional type information. Okay.
So we take in something generically, because we never passed a generic to this. So we have our A is the key. Wait, sorry. A is a value, is an unknown array. Okay. So this is a filter. Okay, I sort of get it. Can you tell me about, so I've seen this syntax with array is, but this would have to return like a
Boolean.
Yeah. That wouldn't work now. Now everything's broken because it doesn't actually. So what that asserts syntax does is it tells TypeScript, if the assertion is wrong, I will throw, just trust me.
Exactly. So usually you would have to, if you want to, like if you're not using the asserts keyword and you're using a type guard, you would need a if clause to contain that like assertion scope. But what assertion does is it says, if we go past this point in the code, this type is going to be like this case. Notably, assertion is a very interesting aspect.
Right. We can't use the arrow function for that syntax. Is that right? Do I have to do that? Okay. T asserts T is not
this
assignable.
Should totally work. I think you want the T on the other side of the equal sign. No. This should be fine. And then you don't need the arrow.
Well, then I have to use the function syntax. Okay.
Sorry. No, the arrow should be fine, and then
it isn't. I think I've read that predicate must be assignable to its type. Is that why this? Okay, actually, I was wondering if this was going to be a bad idea, but actually, I'm kind of learning something. So what we're seeing here, extends string t or never. String.
Still doesn't quite work.
Okay, is key. This is like a different thing. Is string. Okay, we have to make a helper type. Is string. T string true false. Okay. So, and we have to do that. Okay. So if we come over here, is string t extends true.
True.
Okay.
Then we would need a question mark.
They do have one here. Wow. Okay. String never. I just want to see if I can make a thing that will force TypeScript to think something is something, just like that. Think a number is a string or something. That's all I'm trying to do. T extends string. Maybe this won't work in the end. Because what I'd like to do. Okay, so what I'd like to do is say const x equals 1, and then we would say assert is string x, and then you know what I mean?
Yeah, so I can tell you that you can't do this in particular, and this is because of something I call the intersection wall.
You have a name for this?
I have a name for this. I don't know if anybody else does, but right. When you do assertions, you only ever say it's the current type and an additional type. So because you're performing that intersection, you would get number and string, and it would get converted to never, unfortunately.
Okay, T and
Yeah, I don't know if that would be. Yeah, I'm not sure what's going on with that in particular, but I do know that you can't arbitrarily use assertions in the way that you're saying.
The intersection wall. Okay.
Yes.
Mike, the more I listen to you talk, the more I want to listen to you talk. Okay. That's really great stuff. Well, what happened, folks, is basically this issue went up as a PR, as one does, to get something onto the type challenges. Anthony, the creator of the challenges, basically said, what does this requires runtime code? Not sure. Is there a better way to do this? And UID 11 responds back with a kind of like wall of text, for better or for worse. I've read it like 4 times, so I don't know if I really get it, to be honest. But Anthony +1'd it and merged it, and then now it's here. So, again, I cannot help but state this person has done some amazing work, and we've been featuring them on the channel many, many times. I hope they're not watching and angry at us for describing things this way. This is a cool thing, but it's just like, it's a very different sort of thing than the type challenges have been thus far. Actually, I think it's better than what the type challenges have been thus far. Maybe the implementation of this particular one, not so much. But like I have been saying many times, I would love it if the way the type challenges worked is it gave you a real JavaScript function that did the logic of split or, join or Fibonacci sequence or is palindrome or whatever. And our job is to get the type system to reflect what the function is doing. You don't have to write the function, it's already written. I think that's way a better match, way closer of a match to what we do when we develop TypeScript on a day-to-day basis, including library authors. But for better or for worse, this one is not it. And, they have an interesting solution, and I'm glad we got to look through. It's not that long, as you can see. I'm glad we got to look through this part of it with the assertions. I think that's really interesting. I think the rest of it maybe follows from there. It uses unique symbols, and we've seen this kind of thing. So if you're interested more in branding, go watch. It's called Tag, but go watch the video about that, and we talk about this keyword unique, like what is symbol versus unique symbol, all that stuff. If you didn't know about this, the global symbol registry, you have an interesting experience to learn all that ahead of you. And that's that one. What do you think, Mike? Did I miss anything?
No, I think this is a overview of a good overview of this challenging and somewhat confusing problem.
All right. All right. Well, thanks, Mike. And tune in tomorrow because Mike and I are going to be coming at you with the challenge to end all challenges, JSON.Parse. So I'm super duper excited for that one to air. And yeah, I guess we'll see you then.